Welcome back to AI Model Optimization with Intel Neural Compressor. With so many AI model quantization techniques to choose from, where do you even start? Post-training dynamic quantization provides a good balance of optimization, accuracy, and low effort. Quantizing parameters to int8 data types can reduce a model's memory footprint up to 4x and can speed up inference as well. But one of the challenges with mapping to int8 is calibration, figuring out the range of floating point values that parameters can span, a concept we covered in the video in this series on how to choose between quantization techniques. This can be challenging for activations, which vary depending on the model's inputs, whereas weights are fixed after training. Dynamic quantization simplifies the process by treating weights and activations differently. After the model is trained in floating point, it quantizes the weights to int8, but does not quantize the activations. Instead, it inserts functions into the model to quantize activations to int8 during inference based on the observed ranges. So now the matrix multiplications are all int8, and accumulations are then either int16 or int32, which are reduced to int8 if the next layer is quantized. While this adds some runtime overhead versus full quantization of all parameters, it increases accuracy because it can dynamically adjust based on the model's inputs at inference. This approach is optimal for models whose runtime bottlenecks are loading and storing weights in memory, such as transformers and LSTMs. So getting started with dynamic quantization in Intel Neural Compressor can be as simple as specifying in the configuration to use dynamic quantization, then calling quantization.fit and passing in the model and configuration. And this is the same API across PyTorch, TensorFlow, and ONNX. But you also have options to customize this process. So let's take a look at a real application. If you search for Intel AI reference kits, you'll find this collection of applications that you can use to get started. Here we will use the text data generation kit. This has detailed instructions and explanations to get you started, but we will just touch on a couple things. This is based on a GPT-2 model fine-tuned using news headlines. So given a word as a seed, in this case we give it 2 seeds, it generates a synthetic headline for each seed. Just focusing on quantization, our 2 lines are here. You can specify rules by operator type or name. Here it's by name. I'm not sure it's necessary here because we're using an eval function. Even though the eval function is not required with dynamic quantization, it's good practice in order to guide the weight quantization process, and we will cover eval functions in the video on static quantization. But here you can see the tool using the eval function to measure the results and adjust parameters, and if certain operators need to stay in floating point, Intel Neural Compressor will do that automatically. I tried quantizing without the eval function, and the output looked more like this. So you can download the kit and try it yourself and see what kind of headlines it generates without an eval function. The inference script has a benchmark mode, and these take a few minutes to run. So skipping ahead to the results, which show that for this instance on Intel Developer Cloud, quantizing dynamically to int8 gave us over a 1.6x speedup, and of course reduced the size of the model. So if you would like to learn more about Intel Neural Compressor or to try out this reference kit, they're both linked below, or scan the QR codes. And be sure to check out the other videos in the AI Model Optimization series.